Hi and welcome back to chapter number 2 in this lecture series on CCNA cybersecurity operations with me, Joachim Kävrestad from the University of Skövde. And now we are actually getting into the more stuffed chapters. So the chapter lectures will actually be divided into 2 or more recordings so that we don't record too much, because I know from experience that you can't listen to video recordings for too many minutes at a time. I guess the time spent for an average person in 2020 is about 5 minutes, so I'm gonna try to keep it around 15 or something like that. So, chapter number 2 of the CCNA cybersecurity operations curriculum has to do with Windows. And what we're going to do is first look at an overview of Windows, look at the Windows operating system architecture, some notes on the Windows file system or file systems that Windows support, and we're going to look at some common vulnerabilities towards Windows. Then we'll go into Windows administration, look at configuration of Windows, some security related monitoring, the Windows firewall. And I have to say that when we go into these Windows, Linux and network lectures that are the to be covered next topics, they are stuffed with facts. So if it gets too much for you, take a break. I think it can really be needed to take breaks, because it's topic after topic after topic that will be briefly introduced. I've tried to condense it as much as I can, but I still need to cover all the important parts. So that said, this first recording will be the overview part, and then we'll have another lecture or another recording of Windows administration. So let's do an overview of Windows. As you may know, Windows is the by far most well-used client operating systems for computers. Almost everyone used a Windows operating system at one point or another, and we are all, I assume, used to the graphical user interface of Microsoft Windows, where you click around, click next, click finish, click icons and stuff like that. Windows do have a built-in command line interface, actually 2 that you can use, PowerShell and CMD. And the command line interfaces are very practical for scripting, but can also be exploited for malicious purposes. And we're going to get a little bit comfortable with at least PowerShell. And if you haven't worked anything with PowerShell, I urge you to do practicals in this chapter. So let's talk a little bit about vulnerabilities. And vulnerabilities is a key word for this course. And what a vulnerability is an unintended flaw that can be exploited for malicious intent. So, for instance, humans are vulnerable by nature. We only have a skin to protect us, so we're vulnerable to swords and bullets and stuff like that. That's an unintended flaw. It would be much better if we had some sort of panzer as skin. And the same goes with computers. When programmers program stuff, they program thousands and millions of rows of code. And if they do mistakes, well, then they can create a vulnerability that can be exploited for malicious intent. So to minimize the risk of attacks, there are some basic recommendations for Windows operating system security, as discussed in this course. So first of all, we need malware protection and firewall. We need an antivirus program, and we need the firewall to be up to those 2 functions provide a fundamental layer of security. We need to secure automatic services. We need to keep track of what services that run in our network, what services that are automatically started on our Windows machine, and secure or preferably disable those that we don't need. Another recommendation is that we should use encryption. We should encrypt files or our entire hard drive if we have sensitive information, to ensure that no one can read it if they steal our computer or if we just lose it. We should implement a good security policy, and this is where things get fluffy. What is this? Well, we should have routines in our company that are technologically implemented when needed, and culturally implemented when needed. So for instance, users shouldn't share passwords, users should select good passwords, computers should log out when they have been inactive for a reasonable amount of time, stuff like that. We should use reasonable file and sharing permissions. This is a good time to introduce the principle of least privilege. Users should have in a company network access to what they need to perform their work and nothing else. We should use strong passwords, as I said. We can have a full, video series on what I think is strong passwords. I've spent a few years researching that topic. But perhaps most of all, we shouldn't use the administrator account for daily tasks. Users and admins should use normal user accounts for day-to-day tasks, and then, if needed, elevate privileges when they need to perform administrative tasks. And now starts the marathon of different terms. So let me begin with the hardware extraction layer, or the HAL. The hardware extraction layer, or the HAL, is there to make Windows hardware independent as far as it can go. So Windows have to be written to be able to run on almost any hardware. So there are many several motherboard manufacturers out there. There are at least 2 large processor manufacturers. There are several companies doing graphic cards, audio cards, network cards, and so on and so forth. And users expect to be able to install Windows on whatever computer they have. And therefore we need the HAL. So the HAL is code that is between the hardware and the operating system kernel. And the kernel is the core operating system code that handles input-output, such as input from a keyboard or mouse, output to a screen or to an audio device, stuff like that. Kernel handles the memory, and it handles peripheral stuff like a webcam, mouse, and whatever as well. So let me talk a little bit about user and kernel mode. And as it's written in the material, user and kernel mode are 2 different modes in which the CPU operates. And in the user mode, we have installed applications, third-party applications that are installed by the user. And something that is extremely important about the user mode is that the user mode applications have no direct access to hardware or memory location. So you can consider this the untrusted zone, where you run stuff that shouldn't really be trusted. Then we have kernel mode, where we run the most trusted code, the operating system code, and we have direct access to hardware and memory location. And if you want to add something, you can basically say that the kernel mode or kernel level code has access to everything, whereas the user mode applications run sort of sandboxed in their own little world and shouldn't really have access to anything outside of their own world, whereas the kernel mode stuff have access to everything. And this is the reasoning behind this, is that we don't want third-party applications or stuff downloaded from the internet to have access to like the heart of the operating system kernel, because that would be a very big security issue. Okay, moving away from user and kernel mode, and we are moving into file systems. When we store data on a hard drive, we store data using ones and zeros, right? But we have to have some way of structuring this data to make it useful and meaningful for the operating system. And for this purpose, we use file systems. File systems are used to structure data in partitions. And partitions, in turn, are logical containers on the drive. So when we have a hard drive, we may say, okay, this is our physical hard drive. Let's make 2 different partitions. So we have partition 1 here of 100 gigabytes, and then we have another partition of, 50 gigabytes. So now we have our partition. Let's create a file system on it, which is basically how we catalog the data. So Windows support a number of file systems. So we have FAT and exFAT that are considered legacy file systems. They can only hold files up to 4 gigabytes, and they have a bunch of other drawbacks that you can read about in the material. And they are legacy, but they are sometimes still used because of compatibility. So there are, for instance, many video surveillance appliances that can only read FAT file system or FAT32 file systems. It's usually It usually works quite good platform if you use the exFAT file system, so you may still see it out there. We have HFS Plus, which is the Mac OS X default file system. You can read HFS Plus on Windows, but you need special software to do it. We have the X family of file systems that we're going to talk a little bit more about when we get to the Linux part, because it's the Linux default. You need special software to use it on Windows, but you can. And then we have the Windows default file system, which is the NTFS, or the New Technology File System. So talking about the NTFS file system, it stores files as a series of attributes. And what I want to put extra attention to here is that what it allows you to do is connect alternate data streams to a file. So when you have a file that is stored in an NTFS file system, you have first a master file table or an MFT at the beginning of the partition, where you have a pointer to where on the partition the file is stored. And you also have some metadata stored in the master file table. For instance, when the file is created, who's the owner of the file system permissions, stuff like that. But if you for some reason need to store extra information, you can do it by connecting alternate data streams to the file. However, the data in the alternate data streams, or ADSs, is seldom seen at all because, well, no one's using them. And for that reason, alternate data streams are popular to use to store malicious code. And that's what I want you to know about the NTFS file system, really scratching the surface a little bit. From the file system, now we know at least that what file system Windows is using, and from the file system we'll go on to the Windows boot process. So what happens when a computer boots? Well, traditionally we have the BIOS initialization on modern computers, which is basically everyone. We have the UEFI initialization. Followed by that, we have the post and the power on self-test and master boot record, or the EFI files. And what basically happens during this process is that the computer initializes, the hardware is tested to see that everything works as intended, and the operating system is booted or loaded by loading the bootmanager.exe. What bootmanager.exe does is that it reads the boot configuration database, or the BCD, which basically contains any additional code that is needed to start a computer, along with an indication of whether the computer is coming out of hibernation or if it's a cold start. So if the computer is coming out of hibernation, for instance, we just slapped the lid on a laptop, then we want the computer to resume from where it was. And what we do then is that we read a file called winresume.exe, and that in turn read hyperfile.sys, which stores information about the last state of the machine. If the computer is not coming out of hibernation, we have a completely cold start. Then we load the file winload.exe, which in turn create a record of the hardware configuration that's in the registry. We will talk about the registry in a little while. Winload.exe also uses something that is called kernel mode code signing. Kernel mode code signing is something that's there to make sure that all drivers that are used for different hardware is digitally signed. And this should ensure that the drivers are safe to load when the computer starts. So there is nothing hinky going on with our drivers. When all the drivers has been loaded, winload.exe runs, and this is mouthful, ntos kernel.exe, which starts up the Windows kernel and sets up the hardware abstraction layer. Finally, the session manager subsystem SMSS reads the registry to create the user environment, start the WinLogon server, and prepare each user's desktop as they log on. So this is the entire Windows boot process. Leaving that topic and moving on to processes. So what's a process? Well, an application is made up of processes, and one application can actually have many processes tied to it, and the processes you can say the part of an application that runs. So if you open the process manager on Windows, which you will do if you follow the practicals, you can see processes that are associated with the different applications that you have. Those are the processes that does things. Each process will have at least one thread, and the thread is the part of the process that can be executed. And what actually happens when a thread is executed is that a processor, the CPU, performs calculations on the thread. And as I said, Task Manager is what you use to monitor and configure processes. Yet another mouthful with the memory management part. So a computer stores instructions, what to be done in memory or in RAM, until the computer can process them. So each process have access to a virtual address space, that is the virtual memory that the process can address, that the process can use to store data. What you need to know here is that the virtual addresses are not the actual physical addresses. So you actually have a process that maps virtual addresses to actual addresses in the physical memory. A user process, a process that is in user space, runs in its own private address space. And if it needs access to kernel resources for some reason, it has to use a process handle. And this is because user processes are not allowed to directly access kernel resources as a security function. That's what we're going to say about memory management. And before we end, just a few words on the Windows registry. The Windows registry is a database used to store all kinds of Windows-related information, or all kinds of application-related information. But it's designed to store Windows-related information, but non-Windows applications may also store data in Windows registry. And Windows registry is basically 5 hives of settings, user tracking information, basically everything that Windows needs to operate as it does. So, for instance, it stores what settings we want for our desktop, like resolution and such. It stores our password. It stores our recently opened files, so we can quickly access them again. All of that kind of things. And the Windows registry is made up from 5 different hives. HKey current user, that holds data about the currently logged on user. HKey users, that holds data about all user accounts. HKey classes root, that hold data about the object linking and embedding registrations. HKey local machine, that stores system related data. And HKey current config, that holds data about the current hardware profile. So this is a very short introduction to the Windows registry, and in total we managed to go through a few different topics on Windows architecture. So with that said, until next time, feel free to leave comments in the comment field. Remember to have a nice tone. And when we get back for part 2 of this Windows lecture, we'll go through a little bit about how we can manage and handle Windows. So thank you for this, and see you next time.